Hey everybody, in this video we're going to talk about change of base for logarithms, problem type 1. But before we go ahead and dive right into this, let's talk about what the change of base formula is and why it's nice. So here we have the change of base formula. Log base b of m equals the log base a of m divided by the log base a of b. So for instance, if you're told to find the log base b of m and it's not a super nice log to find, we can just take log base 10 of m, or log of m, over log of b. Why is that nice? Because we have log in our calculator, right? We also have natural log, and this is just log base e. So we can take log base e of m over log base e of b, and we can find the same thing. So let's real quick do an example of what this even means so that you can get a better idea of what we're doing. And remember, we want to do this so that we can use our common log or a natural log in order to find a log of any base. So if we were to look at log base 5 of 197 and we were to say, hey, we want to know what this equals. I'm trying to find the value of that expression. Well, I can put this in exponential form and get 5 to the what value is going to be 197. But 5 to a whole number is never going to equal 197. So what we can do is the log change of base formula, which would be, if you remember, this log base 5 of 197 would be log base 10 of 197 over log base 10 of 5. This is equal to the log base 5 of 197. Okay. It should also be equal to the change of base formula when we use the natural log. The natural log of 197 divided by the natural log of 5. When you plug these both into our calculators, the log of 197 divided by the log of 5, we get 3.283 for this side. And then for this side, we also get 3.283. So our expression is equal to the log base 5 of 197. We will get, no matter which change of base formula we do, we get the same thing because that's what our expression is equal to. Now to check this, I'm going to do a little check here. What was our goal? We wanted to find out what 5 raised to what power was equal to 197. So if you were to plug in 5 to the 3.283, we would expect to get 197, which we do. Okay, so the change of base formula works. Now let's do some examples. For this first example, we have log base 4 of 18, and we're trying to figure out what that equals. So what we're saying is 4 raised to what power is going to equal 18. That's a hint on how you're going to check it, okay? Change of base formula says this question mark, or what the value of our log expression, is going to equal log of 18 over log of 4. Or natural log of 18 over natural log of 4, but we'll get the same thing. When we plug that into calculator, we'll get approximately 2.085. And you can check it. Now I want you to do similar reasoning and see what you get here. And to check your work, you should get 1.892. Okay. So pause the video and check your work. I'm going to go ahead and write down my work here. This is going to be equal to the natural log of 21 over the natural log of 5. So On the left hand side I use the log, on the right hand side I use the natural log, but this is also equal to the log of 21. So log base 10 over 21 over log base 10 of 5. Okay, let's do one more set of examples. So even though there are fractions, we're going to treat this the exact same way. And we're going to take the log base 10 of 1/5, divide it by the log base 10 of 1/3. That's our change of base formula. And it's going to be equal to 1.465. These are all approximations. They're not actually going to be equal to because we get some decimals, right? And for this one, I want you guys to do on your own and eventually get to this answer. Negative 0.774. Why would we have a negative number? Well, this is 1/6 raised to what power? It's going to equal 4. Right? So a fraction needs to be raised to a negative number in order to equal a bigger positive number. That is change of base formula.